So Sarah, you asked if we could briefly go over JWTs tonight. We can if we have time. I'm not sure how much time we're gonna have at the end of the lecture. If we do, we can briefly go over it. We'll see. All right, how was the project for everyone? Any questions? Fairly straightforward. Make sure you get the project for tonight cloned down and installed. You shouldn't need any extra dependencies. All right, so let's take a look at where we left off on Tuesday. The project that you cloned down tonight should be really similar. I just added a couple things. So where we left off, we've got our index file, our auth router, we're hashing our passwords. I added an additional protected route in the auth router just so that we can have some more protected routes versus the one. We have our users model and our users router. Okay. So if you remember when we left off, when we make our requests, so if we clone the project, npm install, and start the server, run server. If you remember, when we make a request to a protected route, or let's say we log in first, or register first and then log in. When we try to make a request to our protected route, our get users route, remember we have to send our username and our password as headers. Notice how it takes a while to make that protected endpoint request, right? It still takes about 1.5 seconds. Why is that? Why does this protected endpoint take 1.5 seconds? It's not going over the internet. It's not doing anything crazy. It's just all local. Why is that taking so long? All right, time clock, or the time cost, the time complexity. Remember, we have to essentially, in order to authorize the user, we have to re-authenticate them every single time with their username and their password. Okay, meaning we have to hash the password using bcrypt on every single request, which means our time complexity is intentionally slowing down every single protected endpoint. Okay, we don't want that. We don't want every single protected endpoint to be slowed down by our time complexity. We only want our slowdown to occur during the authentication phase, right? Like when you're logging in or when you're registering, not during the authorization phase, okay, which is when we're calling a protected endpoint. We don't want the slowdown to happen during the authorization itself. Otherwise, our entire API would be slowed down for no good reason, right? So remember that the HTTP protocol is stateless, meaning it doesn't remember anything about us between requests unless it gets saved to a database somewhere. Now this includes authentication information, which is why we have to send our username and our password as headers for every single protected endpoint. So if you remember back in the React lessons, how did we solve this in our React front end? What did we do so that we didn't have to send our username and our password over and over and over again? if you think back, remember we essentially exchanged our login credentials, we exchanged our username and our password for an authentication token. Okay, and then we saved that token to local storage and sent it as a header for all of our protected endpoints. Okay, that's how we kind of got around that issue of having to send our username and password for every request. So that was on the consuming side of that whole flow, right? Meaning we just took the auth token and used it to authorize ourselves. But we didn't really know where it came from or what it meant or how it got generated. So now we're going to look at it from the other end, from the providing side, okay, and see how that token gets generated and how it gets used. So if our API, if it wants to remember that the user was authenticated, it needs to essentially write itself some kind of reminder, right? Keeping this at a very, very simple level. If we just think about this at a very simple level, what's something that we could do to help the server remember that it authenticated someone? What's a really, really simple thing that we could do to help the server remember that it actually did something? Okay, we're not talking about cookies or sessions yet. We're just keeping it really, really simple. From a simple perspective, what's something we could do to help the server remember? How about just storing something in a variable? Storing something in a variable that's in memory, right? That's pretty much as simple as you could get. And that helps the server remember something. So how about when a user is authenticated, let's say that we give them some kind of a token to send as a header in later requests. Let's just say that that token is a random number, okay, for our purposes right now. Say that that token is just a random number that we generate in JavaScript. We're going to store that random number in a variable, and then that variable is going to help the server remember that it actually authenticated that person, okay? And it's going to send that number back to the user, and the user is going to send that number back as a header, as like a token header. Let's just implement that really quick to solve this problem of every one of our protected endpoints taking forever. So start your server, open it up in your code editor. And we're going to open up the auth router file. Okay, let's just implement this really simple idea of storing numbers in a variable that essentially identify users that have already been authenticated. So if we wanted to do that, let's just make an object just at the top of the file, right below a router. Let's say const tokens equals an empty object. This is where we're going to keep track of people that are logged in. Okay, now inside of our login function, let's create a new token if the user is validated. So if the username and the password is correct, let's just create a token by saying const token equals math.random. Okay, that's just going to give us some crazy random number that we can assume is our authentication token for our purposes, for our really simple system of doing this, of helping the server remember. And then let's assign that token that we just generated, just assign that to the object that we just created. So we can say tokens at the index of token and just assign the user that's currently logged in or that just got validated. And then for visual purposes, if you want to just log out console log tokens just to see what we currently have in the server's memory. And then let's send that token back to the user, just as part of that response payload. Just say token, token. so that they can see what the actual token is, what their auth token is. Okay, so that essentially solves the first part of this, right? We're generating an authentication token. We're sending it back to the user. We're storing it in this variable, which as long as the process doesn't end, it's going to remember which variable is associated with which user, right? Which token. Okay, so save that file. Remember to define tokens at the top here. It's just an empty object. We're defining it outside of the route handler, so that's going to be persistent even between many different requests. That's not dependent on the current request. That's for all requests since it's not in a route handler. Let's just see what this does. Okay, first off. So if we go make a request to log in now to your login endpoint. So we're going to make a post request to auth/login. We're going to send our username and our password. And let's just see what it does. Okay, so it gives us this token, which is just a random decimal number, right? It's just this long random number. So in this case, we can just assume that our auth token is just this number. This is how the server is remembering that we're authenticated. So now inside of our protected endpoint, what if we wanted to check to make sure that that user is validated? What would we want to do? Right here in this protected endpoint right below. Just a really simple way of validating that that token is valid when the user sends it. We just have to check to see if it exists in that object, right? So let's pull it in from the headers. Let's say const token. We're gonna send it as a token header. Pull it in from the headers and then just see if it exists, right? We can say if there is no token or if the token doesn't exist in that global object, right? That object that we're using to remember. So if no token header is sent or if the token doesn't exist in that object, then we can assume that the user's not validated, right? Because they're not sending a correct token. So in that case, we can just return some kind of an error. We can say return res.status, give it a status code of maybe 403. Give it a response message of you are not authorized. Okay, and save that. Now go and try and make a GET request to this protected endpoint. Just go try to make a regular GET request to auth/protected and see what you get. So if we jump over, try to make a GET request to auth/protected, just a regular GET request, no headers, nothing, just make that GET request. And we get a you are not authorized message, right? But now if we log in, take that token that gets returned to us, right, that number, and send that as a header to our protected route. So we copy that token, we go into protected, we add a header that says token and put your token value in there as a header. And send that, we're now authorized. Okay, and it only took 2.19 milliseconds instead of 1 point whatever seconds, because we're no longer rehashing that password, right? Instead of taking a username and a password, we're taking some kind of token. In this case, just a random number. So this is a very, very simple way to solve that problem, right? That problem of having to rehash the password on every single protected route. Instead of rehashing, we're giving the user some kind of token, some way so the server can remember who they are. We're storing that token in memory, just using an object. We're giving that token to the user. The user sends that token as a header, and we just validate it by checking to see if it's in that object. Pretty simple, right? And remember, since this is pulling from memory, right, these tokens are sitting in this object just in memory. If your server ever restarts, that object gets reset and all your sessions are gone. You start from scratch. So this is a very simple way to remember who was authenticated and who wasn't. Obviously, it's not very scalable, right? It's not very secure at the current time, this current implementation, but it gets the job done. So maybe like in our case, maybe a random number is not the best way to represent that token. Right, there's several different ways to represent these tokens. Right now, we're just using a random number, right? We're just calling math.random to generate a token. But there's actually several different ways to represent these tokens. One of them being sessions, which is what we're going to learn about tonight. Another one is JWTs, which is what we're going to talk about, or what you're going to watch the video on Tuesday. But essentially, we're just remembering who's authenticated and who wasn't just by assigning them some kind of value and storing it in the memory, okay? So we just created a really, really simple implementation of a session. Okay, this is what a session is, essentially, under the hood. This is what it's doing. It's assigning some value to the user, storing that value in the memory, and it's using that value to remember the user in later requests. Bradley, he asked, doesn't saving the token in the server's memory break REST principles? Yes, it does. Because REST by default should be stateless, right? Which is why the concept that you're going to learn about next week with JWTs helps fix that issue. But for now, we're dealing with state. So we just created a really simple implementation of a session. Sessions are just a way for the server to preserve info about a client between different requests. It's to remember that someone is authenticated, right? So right now we're just storing these sessions in memory, right? We're storing our simple sessions just right in that object. It's just getting stored in memory. Meaning if we restart our server, it's going to be cleared out and essentially everyone that was authenticated is no longer going to be considered authenticated, right? What are some ways that we could persist these sessions or persist these tokens between server restarts? Like what if we wanted to persist them somehow? What are some different ways? By the way, yes, Cliff, that's a very good explanation of what we're talking about. It's like getting a wristband at a music festival instead of showing your ticket every time you want it in. Exactly, yep. You go to the music festival, you give them your ticket, that's like logging in. They give you a wristband, that's like getting a token, an authentication token. And from that point out, if you leave the festival and come back in, you don't have to give them a ticket again, you just flash your wristband and they let you in, right? Same concept. So what are some other ways we could persist these sessions between server restarts? Well, we could use a database, right? We could just store these tokens in a database instead of in that object. We could store them to a memory cache, something like Redis or Memcached. We could store them in some kind of NoSQL database like Mongo or a SQL database like SQLite. Maybe if you have some crazy reason, you could store it to like a file on the file system. That would work too. Storing them in memory is the easiest way to do it, but it's not very practical. I mean, imagine if you had 100 people logged into your app using this implementation, and you had 100 different tokens in your token object, right? And imagine you had to deploy an update to your API, and in order to deploy that update, you had to restart your server. In that case, anytime you deployed an update, your server would restart and 100 users would have to log back in, right? It would log them out every time they tried to, or anytime you tried to send an update. Not good, right? So yes, this is a simple implementation, but it's not always the best one. There's a little bit more that goes into sessions, right? This is a really simple implementation of a session, just storing something in an object. But there's more that goes into actual sessions, things like limiting the session to like a specific device, or limiting the session to an IP address, or giving them expiration times, or persisting between server restarts, right? There's a lot more that goes into an actual session than what we just did. But luckily, we don't have to write all that from scratch. Once you understand how a session works, you can just use some library to help with the actual implementation of it. Okay, so now that we understand how sessions work, essentially under the hood, right? They're just storing something in an object or storing something in memory. We can now just use a library to simplify that whole process and make it a little bit more fail-safe, make it a little bit more secure. Okay, any questions so far? Are we all on the same page? Oh yeah, that would not be good if you were in some game and you had a lot of progress or something and they wiped out all your progress with a big patch. That would be horrible. Yeah, you never want user data to be lost, even temporary user data that sits in memory, right? You don't want that to be lost either. It's really annoying to have to relog into stuff. You probably don't experience it very often, but when you do, it's kind of annoying, right? If you're like trying to go look at something on Facebook or something and you go to facebook.com and it prompts you to log in again, that's kind of a halting thing, right? It takes a while to actually type in your username and password and load the page and maybe do two-factor auth and all that. It's nice to just stay logged in and be able to go directly to what you want to see. Imagine how horrible it would be if we didn't have sessions. Like, let's say anytime you went to a different page, you'd have to re-log in. Like every single time you looked at something, it would be a terrible UX experience. So these sessions kind of help with that whole flow. All right, so we understand what sessions are, what they're doing under the hood. Let's install a library that makes our lives a little bit easier, that makes our sessions more secure. So there's this library called Express Session. Clever name, right? Let's check it out. Express Session. It's a simple session middleware for Express. So this is a middleware library that we can install. And it allows us to create sessions on our machine in memory. Okay, just by defining some middleware, just by calling app.use and passing our session middleware to our application. We can define some options. We're going to talk about each one individually. So let's install Express Session. So just npm install express-session. Oh, and by the way, I forgot to show that. If you look at our logs, when a request is made, you can see our current list of sessions, right? Our current object of tokens. You can see in this case, that token of that random number is associated with my account, right? If you had multiple sessions in here, you'd have multiple tokens that were associated with multiple different accounts. Kind of nice to just see it visualized like that. So if we npm install express-session, should actually already be installed. So you shouldn't have to wait too long for that. Just you can type it again if you want to practice. And since this is going to take care of most of our manual session implementation that we have going here, we're not going to need most of this code that we just added. So we're going to replace all of this stuff. So first things first, let's bring it in. Let's actually go into the index file, index.js, and let's import that library. Okay, so we can say const next session store, what we're going to call it, or not next session store, sorry, session, next session store is the next one. Call it session, and then require express dash session. Okay, session equals require express dash session. Session. And then we're just going to use the middleware just by calling server.use and pass through session. It's just a function that we call. Okay, if we take a look at the documentation, you'll see that it takes an options object. When we call session, we can pass some options just as an object. So let's pass a few options. So give that an object. And let's specify the option resave false. Okay, if you look at the documentation, resave is, where is it? Resave. It forces the session to be saved back to the session store, even if a session was not modified during the request. We don't want that. That's something that might take a little more resources than are needed. So let's set that to false. Okay. Next one is, let's say, save uninitialized to false. Save uninitialized to false. If we look at the documentation for that one, save uninitialized forces a session that is uninitialized to be saved to the store. A session is uninitialized when it is new but not modified. So we want to set that to false for a number of reasons. We're going to talk about them a little bit later. But it's reasons dealing with certain laws in certain countries. It's actually really interesting, but we want to set that to false. Just set it for false. Set it to false for now, and then we'll talk about it later. And then the third one that we have to specify is a secret key. Okay, so the session library under the hood is going to do some fancy stuff with cryptography and encryption, and it's going to make our sessions a lot safer than just how we were doing it before. It's not just like not just a random number stored in an object. It's going to encrypt some IDs, and it's going to do some fancy stuff. So in order to allow it to do its fancy stuff under the hood, we have to give it some kind of encryption key, some kind of secret. Okay, so just give it some kind of string. You can put whatever you want in here. Training Kit always has this, keep it secret, keep it safe. For any Lord of the Rings fans out there. It's actually really interesting because depending on the curriculum we're looking at, you can see like the personalities of the instructor that actually wrote it coming out. Luis really likes Lord of the Rings, so the back end references are always Lord of the Rings. And then when you're looking through the front end stuff, Dustin really likes Star Wars, so you'll like always see Star Wars stuff in the front end stuff. It's really interesting. Anyways. Okay, so those are the three options we need just initially. So just put those three in there. And now we have our session middleware installed. Okay, we'll talk about these last two. We're going to talk about these more in depth in just a minute. So just put them in there for now, and then we'll talk about them later. Ah, thank you. Typo. Unannealized. Uninitial. Where am I? I'm missing the N. Thank you. Spelling is hard. No, that's not right. Uninitialized. There we go. That looks wrong still, but I think that's right. I'll just copy it from the documentation. I had it right. Cool. So now that we're using this session middleware, we can jump back into our auth router and use it. All right, so we're going to replace our custom implementation of sessions with this library. So we no longer need to store these tokens in that object, so just get rid of that. Okay, get rid of that tokens object. Come on down, and we no longer need to generate a random token using a random number, so get rid of that. Get rid of everything we added, essentially. Get rid of that token in the payload. And just comment this one out in the protected route because we might be able to reuse some of that stuff. Okay. Bradley, is that secret key something you'd want to set in a .env file? Yes. Yep. That is something, if you were deploying this to production, you would want to set that string to an environment variable so it's not sitting in your code repo, right? Because that's a secret value. That's an encryption key. You don't want that in your code. You want that extracted into an environment variable. We're not going to do that right now, just for the sake of time, but it's good to keep in mind if you ever have sensitive values like encryption keys or API keys, pull them out of your code. All right, so now in our login, instead of doing what we were doing before, instead of generating that random token, sending it through as the payload, we now have this special object that we can work with, which is request.session. Okay, request.session is this object that Express Session gives us that can essentially hold any data for the current session that we want. So remember before how we were assigning the value of user to our current session just by assigning it to that token value, right? Well, instead of doing that, we can just now assign that user to the session object. So we can say request.session.user equals user. And that value that's saved to the session, that's going to be able to persist between requests now because it's stored in the memory, right? It's stored as part of the session. So we come through, we're logging in, we validate the username and the password, we hash it, everything looks good. The user is authenticated, store the value of their user account in the current session. Cool. So now if we jump into the protected route, we can check to see if the session is valid. So that request.session object, that's going to be available since we installed Express Session as middleware. This request.session is going to be available in any single one of our route handlers. So we can use it in the login route handler. We can use it in the protected route handler. We can use it in other middleware functions. We can use it anywhere, as long as it's something that comes after the session middleware in our middleware chain. Okay, so request.session, that comes from this session middleware right here. So anything that comes after this in our middleware chain, it has access to request.session. So since we assign the user to request.session.user in this middleware function, it's going to persist that value. So inside of our protected route, we can now check for it. So we can say if there's no session, so if the user's not logged in and there's no session, or there's no session.user. So if neither of those values exist, then we automatically know that the user's not authorized. They haven't been authenticated yet. So then we can just assume that they're not authenticated and return an error, right? We can say return, actually we can just copy the same error that we had below. The status of 403, you can just copy that and reuse it. And then get rid of everything else. And that's it. We've now replaced our custom session code with session code that automatically does a lot of stuff for us. So now when a user logs in, a session is going to automatically be generated for them. It's going to be saved in the memory. It's going to include information about the user. And then it's going to essentially save that in the memory. And then when a user comes and makes a request to a protected endpoint, we can pull their data out of the current session if it exists. So save that and try to make a request to log in and the protected route again and see what happens. So save it, restart your server, jump into Insomnia. I'm going to make a request to log in. Okay, with the same username and a password. We should get welcome, get a 200 OK. Notice that we don't get a token. Okay, we don't have a token in our response payload. But if we go into our get protected route and try to make the request without any header, we no longer need that token header. Just a regular request, right, to auth protected. No headers, no body, nothing. And it authorizes us. Okay, it remembered that we were logged in between requests. The server was able to tell that we already logged in the login route. And it knows that we're authorized when we try and access this protected route. Okay, even if you try and restart your server, so stop your server and then start it again, and try to make a request to get protected that now without logging in, you're not authorized, right? So we haven't logged in yet. Remember, we're storing sessions in memory. So if we restart the server, that session is going to be cleared out. So we're no longer authorized. We can't get that endpoint. But if we hit the login endpoint again, it's going to generate a new session for us. It's going to store it in the server's memory. And without us sending any additional details to that get protected route, it's going to know that we're logged in through that session. Okay, so we don't get a token when logging in. We don't have to send a token header for the protected routes. We don't have to do any of that. The server just knows The server knows that we're already authenticated because of these things under the hood called cookies. So under the hood, sessions use these things called cookies. Before we get into that, let's take a 5-minute break. Give you a chance to catch up, ask any questions that you have in Slido, and I'll see you in 5. Okay. So how is this actually working under the hood? What is it actually doing? Well, we're going to figure this out. Give you guys a few minutes to get back here. Sometimes I creep on your cameras after breaks to see how many people actually come back. So if you don't come back, I know. Okay, so notice how when we make that request in Insomnia, we're not sending any tokens. We're not sending any identifiable information in that request. You know, our login request doesn't return a token anymore. It doesn't return anything that we can use. This request is just kind of a mystery, right? We don't really know how the server is identifying us. How does it know that we're logged in? Is it by our IP address? Is it by our device? Or like, how does it actually know? And the answer is these things called cookies. Okay, sessions use these things called cookies under the hood. So cookies are something that's really old in web development. They're these things that have been around for quite some time. And they're a way for clients, like browsers and Insomnia, they're a way for these clients to store data, essentially. Okay, they're simple key value pairs, which are passed back and forth between the client and the server. So it's kind of like local storage, but it's more automated. It kind of happens behind the scenes, you know, because we can't see it happening right now. We can't see that a cookie is getting sent, but it actually is just behind the scenes. So cookies are a lot like local storage. They come with some additional features, things like they can be encrypted, which is a big thing. They can prevent JavaScript from reading them. They can have an expiration time, like they can actually expire after a certain amount of time or at a specific date. They can be specific to domain names, so like these cookie jars, what we refer to as like multiple cookies. They can be specific to domain names. So like cookies on lambdaschool.com can't be accessible to google.com, right? When you set a cookie, it's only available to the domain that actually set it. And most importantly, the thing that kind of brings this all together is they're sent automatically. They're stored automatically and they're sent automatically based on the request's headers. Okay. So remember our HTTP protocol? Remember our diagram? Remember every HTTP request, it has request headers, it has a request body, it has response headers and a response body. Right, and these headers, these request headers and these response headers, this is how the server and the client kind of communicate metadata to each other. So if a server ever responds with a specific header for cookies, then the client knows to set that header, or to set that cookie, excuse me. And if the client ever sends a cookie header, then the server knows to look at that cookie for specific information. So look at the headers for our Insomnia request. Look at the headers for our login request. Go back to login, and if you look at these headers that get returned, there's this strange header called set cookie, and it has this crazy value. So if a server ever responds with a set cookie header, then the client, whatever it is, whether it's Insomnia or a browser or Postman, that client, it knows to set this value in a cookie, in some kind of local storage, right? Some kind of local value specific to that client. It stores it in what's called the cookie jar. Okay, it takes these cookies and it puts it in the client's cookie jar. And that cookie jar is specific to this domain. So in this case for localhost has a cookie jar that now contains this cookie. Okay, because it received that set cookie header. This is all automatic. It happens behind the scenes. And then in all subsequent requests to localhost from Insomnia or from your client, anytime it makes a request now, it's going to look in our cookie jar. It's going to see if our cookie jar contains any cookies. If it does, it's going to send those along with the request automatically. So if you look at our get protected route, look at the, actually, I don't know if you can see the request headers. Let's log those out just so that we can see them. Go into your protected route, and before everything, just console log your headers. Request.headers. Now if we log back in and make a request to get protected and look at your request headers, you see that Insomnia is setting this header or sending this header called cookie, and it contains that same value that the set cookie header had when it received it from the server. Okay, so that's how cookies work. It all happens behind the scenes automatically, the client and the server communicating with each other. The client knows that whenever it receives a set cookie header, it takes that cookie, takes that value, and it puts it in the cookie jar. And then for every subsequent request, it checks the cookie jar to see if there's any cookies. If there are, it sends them along as a cookie header, just like that. So the server can now look at this cookie header and validate the session based on that value. So if a client is sending every single cookie in the cookie jar for every single request, is it problematic that the cookies are sent to endpoints that aren't even protected? Like if we call welcome, all our cookies from the cookie jar are going to get sent to that request too. Is that problematic? What do you think? If we come into our index file and let's log out our headers in the root route, and that right before we get that welcome message, let's log out our headers. Console.log request headers. And your server's going to restart, so you'll have to relog in. And now go to welcome, make a request to welcome, and look at the headers for welcome. We still have the cookie, right? It's sending that cookie even though we don't need it. Is that problematic? Nope, that is not problematic. And the reason is the cookie header, it's going to get sent for every request, even if they're even if the cookies in the cookie jar don't pertain to that specific endpoint. But the server just disregards it, okay? That's the cool thing with headers. You can send as many headers as you want with your request, and the server only uses the ones that are needed. All the rest it just ignores. So it makes it really easy, right? The client just, all it has to do is it doesn't even really have to think about it. If there's cookies in the cookie jar, send them with every request. That's all there is to it. And then the server is the one that says, all right, I need this header, and I need this header, and I need this header. Disregard all the rest. I don't care about the cookies. I don't care about anything else for this welcome route. Or maybe it's a protected route and it actually does care about the cookie. Then it's going to be there when it needs it, right? So this happens all, yes, this is actually a kind of an interesting topic because this all happens behind the scenes, right? You don't know when your browser is setting cookies. You don't know when it's sending cookies. And it results in a lot of issues dealing with privacy, right? Because we don't know what they're saving in our cookies. We don't know if they're saving personal information and sharing it with third parties. We don't know what they're doing with that information that's getting sent in these cookies because it all just happens automatically and we don't really know. right? So it gets kind of concerning when you talk about privacy, which is where all of these new laws are coming from. These laws like GDPR, right? And there was I don't know what the name of the law in California was, but they just passed another law in California that essentially limits the data that you can store in cookies as well. So this is how, like think about it. If you go browse a product on Amazon and then you see that product advertised on Facebook later on, it's because of these cookies, right? When you're on Amazon and you're looking at that product, Amazon is going to save something to a cookie that says, hey, Jason was looking at this product. And then when I go to Facebook, Facebook has access to those Amazon cookies because Amazon gives them access to those cookies. And they can now see what I was browsing on Amazon on Facebook, right? And they're able to link those two pieces of data together. CCPA, is that what it's called in California? So let's look at an overview of this whole flow that we just saw. Let's look at that overview of what just happened. Okay, so the first thing that happens, the client is going to send some credentials to the server, right? A username and a password. At that point, the server is going to verify those credentials. It's going to make sure that the user exists in the database. It's going to make sure that the password is correct. It's going to check the bcrypt hash. If it's verified, if everything looks good, the server is going to create a session for that client. Okay, it's going to create a session and it's going to save it somewhere, whether it's getting saved in a database or getting saved in the memory. It's going to persist it somewhere, that session data. And at that point, the server is going to send back the cookie with the session data as a header in that set cookie header. Right? At that point, the client is going to store that cookie in its cookie jar so that it can reference it in the future. And from then on, the client is going to send the cookie on every request. And then when the server receives that cookie, it's going to verify that it's valid, right? It's going to verify that that session actually exists by checking it in the database or checking it in the memory, making sure it's actually there. And if it exists, then the server considers the client as validated, as authorized. And the server is going to provide access to the resource. Okay, that is the session cookie flow. That is how authentication happens on most websites on the internet right now. So anytime you go log into Facebook or log into some website, this flow is going to be happening to some extent, right? Maybe some small details or implementations will be different, but this is the overall idea of what's happening. All right, let's take a look at some of the other options in Express Session related to cookies now that we understand what cookies are. So if we jump back over into the documentation, we've got a lot of stuff pertaining to cookies Because express session, it actually sets cookies for us, right? It deals with all these cookies automatically for us. So it gives us some options. Okay, the first option is under secret. We actually already used this one. It's a required option, okay? So this is the secret used to sign the session ID in the cookie. So if you go look at the cookie that gets returned in Insomnia, if you click on this cookies button right up next to no environment or under the workspace name, click on the cookies button and you can look at your cookie jar. Okay, this is your cookie jar. So we've got one cookie set for localhost and this is what it contains. And if you look at the session ID, it has connect.sid, which stands for your session ID. It's this long, weird looking string, right? It's not just a number. And the reason is that session ID is encrypted. It's encrypted with the key that we specify in secret. Okay. It's just another level of, or it's another layer of security that kind of helps keep our sessions a little more secure. Okay, and then going back to save uninitialized, remember how we have a lot of laws surrounding cookies right now. Things are getting more and more strict. We have GDPR, CCPA, a lot of different laws that says we can't set cookies for clients unless they give us permission, right? That's why you see all those annoying permission pop-ups on websites that say, can we set cookies? Like, is this okay? It's because of these laws. So we have to set this value to false, save uninitialized, because we don't want to accidentally set a cookie if we don't have permission to. Okay, if a user logs in, if they try and authenticate themselves, then by default we have permission to set a cookie with the session information. But if they don't log in, they're not doing anything, we can't just set a cookie. Or we shouldn't. I mean, we could. We'd probably be fine. We'll probably get away with it. But if we were a big company and we were doing that, we'd probably get in trouble. So we set that value to false. Let's look at some of these other options. So under the cookie option, the cookie object, we can specify an object under options that's called a cookie. And we can specify specific options for the cookie, right? We can set the domain that has access to it. We can set a date that the cookie expires, that it automatically gets deleted from the client. We can set HTTP only, which means that the cookie can't be accessed with JavaScript. Okay, that gives us a little bit of extra security there. You don't want your session IDs to get leaked to some third-party browser app, right? If we limit cookies to HTTP only, it means JavaScript can't access the contents of that cookie. So let's set that. Let's actually set that to true. That's a good one to have set to true. So if we jump back into our config, we can add a cookies object. Actually, cookies singular, not plural, cookie singular. And we can say HTTP only, true. Okay, let's look at some of these other ones. We've got a max age. Okay, so that's specifying an expiration time in milliseconds instead of an actual date. So expires, we can set the date to like February 1st of this year or May 15th of next year or whatever. But with max age, we can actually specify the expiration time in seconds, in milliseconds. So let's say that our cookie expires in 15 seconds. Let's say once you log in, you have 15 seconds to do whatever you want, and we're automatically going to log you out after that time. So set max age in your config to 15 seconds. And remember, the value is milliseconds. We specify the number in milliseconds, and there are 1,000 milliseconds in 1 second. So to specify 15 seconds, you just say 1,000 times by 15. Okay, there's a few other options if you want to look through this documentation. You can set expires, domain, you got path. You can set a path for the cookie that's part of the URL. So it's only set for a certain endpoint. Same site, secure. You can set the secure Boolean if you only want the cookie to be processed over HTTPS, which is probably something you'd want to do in production because HTTPS is encrypted. Regular HTTP is not encrypted. And since we're sending sensitive information with our cookie as part of the header, you'd probably want those headers to be encrypted. So you would set secure to true in production, right? We'll set it to false, but in production, this should be true. So the cookie header is encrypted. And you can look through some of these other options if you want to. Those are the basics. Okay, let's check this out. So we set the max age of the cookie to 15 seconds. So if we jump back into Insomnia, our server, restart our server, and log in. So we log in, session is created, try and get protected endpoint. It works, all right, we can make as many requests, works fine. But after 15 seconds, that cookie should expire and we'd no longer be authorized. So let's give it 15 seconds and boom, there we go. Now we're getting a 403 forbidden because our cookie expired. So it essentially logged us out. 15 seconds might be a little low. Maybe we could set that to 7 days. So we can essentially require the users to re-log in every 7 days. So we could say 1,000 milliseconds times by 60 seconds, times by 60 minutes, times by 24 hours, times by 7 days. Or you could just put the value of milliseconds for 24 days or for 7 days, which is what? 604,800,000 milliseconds. All right. Actually, I think I missed a number there. We want to do 60 seconds, 60 minutes. No, I think that's right. Yeah. Oh well. All right. Let's do a challenge. 5 minutes. Let's update our restricted middleware. So if you remember, we had that restricted middleware that we wrote on Tuesday. I extracted it into this middleware file, but it's everything that we wrote on Tuesday. So take 5 minutes and update this middleware function to check for a session instead of checking for the username and password headers. Take 5 minutes and do that. Update our restricted middleware function to check for a session instead of checking for username/password headers. I'll leave this open for your reference. And the clock starts now. Okay, while this is going, Sarah, I'm going to answer your question. You asked, how do we know what time increments to use for cookie session timeouts or shutoff, etc.? It just comes down to a decision that you and your team have to make, right? If you want your users to have to log back in after 7 days, then you would set your cookie expiration to 7 days, right? If you never want them to have to re-log in, then you would just set your cookie expiration to infinite. You just wouldn't set an expiration. It just really depends on what kind of application you have and what kind of security processes you have. For like a bank account, for example, if you go log into your bank account and just let it sit for like a half an hour, I guarantee they're going to log you out automatically, because the bank account is high security stuff, right? You don't want just an open bank account sitting there indefinitely. So it just depends on the type of application that you're building. Okay, and Steven, I think I answered your question as to how the session config object works to encrypt the cookie. Just encrypts that session ID. Okay, 2.5 more minutes, see if you can get this figured out. One more minute and we'll go through it. Maybe 5 minutes was a little too long for this one. We're mostly just deleting stuff. All right, who was able to figure it out? Totally okay if you weren't able to get it. We'll go over it. All right, so we're about half and half. All right, let's just go through it. So jump into the restricted middleware file. And this is actually going to be really easy. All we have to do is essentially cut out all of this stuff. Because remember, this is the code that's making all of our protected endpoints take forever. Because it's rehashing our password with bcrypt every single time. So we can just get rid of most of that. Actually, all of it. We can just get rid of all of it. Comment it all out. And then up above, all we have to do is run that if statement that checks for a session. Same one that's sitting in our protected route. Okay, remember that request.session, that's available in all of our middleware functions, all of our route handlers, everything. So we can just run this exact same if statement inside of that middleware function. So inside of restricted, we can just say if the request session doesn't exist, or if the user doesn't exist, then just return that error. Return that same error that we were using before. That's actually it. That's all we need. We can get rid of everything else. We don't even need the try catch statement anymore because we're not doing any async await, right? So we can get rid of the try catch statement and simplify it even further. That's all we need. We just need to check for that request.session if it exists, and if the user exists, then we're good. If they don't exist, then return an error. So now inside of our auth router, instead of using that if statement right here, we can now just use the middleware. So cut that out and import the restricted middleware. So we can say const restricted equals require // middleware / restricted, and just call restricted. It's going to have the same effect that we had before, except we're doing it through middleware now instead of directly in the route handler. So if someone goes to /auth / protected, it's going to go to the restricted middleware first, sets an error to the object if we need to reuse it. We actually don't even need to reuse that auth error variable anymore since we only use it once. So you can just put that in line and get rid of the auth error variable. So it's going to come to this middleware function and it's going to say, is there a session? Okay, if there is there also a user in that session? If not, then we're going to return this invalid credentials error. And then the request just ends there. It doesn't move on to any more middleware. If there is a session and there is a user in the session, then we're just going to call next, which moves on to the next piece of middleware, which in this case is the route handler, right? Just going to move directly to this one. We're already authorized. Once we get to this point, we get to this route handler, we've already been authorized. And we can move on to do whatever we need to do. So yeah, now in this file, we can also get rid of the bcrypt import. Actually, no, because we're using that in login, so we can't get rid of that. But we can get rid of it in restricted. If you go into restricted, we're no longer using bcrypt. And we're also no longer using users model. So we can get rid of both of those imports. In restricted, not in auth router, in restricted. We're still using those for the post login in auth router. Cool. So now if we save that and we try to make the request in Insomnia, try and log in. No, make sure you start your server. Try and log in. Sets a cookie behind the scenes, right? Now try get protected. We're authorized. Try get users. We're still authorized, and it doesn't take 1.5 seconds, right? We no longer have to send these headers of username and password. We can just send the request, then Insomnia sends our cookie for us. Cool. So let's move on to the next section, which is logging out. So we've seen already that we can kind of force a user to log out just by setting a max age on the cookie, right? With our current setup, the user is going to automatically be logged out after 7 days. But what if the user intentionally logs out? Like what if they click the logout button? Do we do anything beyond that? We probably shouldn't just keep the session valid even if they specifically log out, right? We should probably get rid of the session. So in this case, we just need to delete the session. We don't need to delete the cookie, we got to delete the session. So let's go into our auth router and let's create a new route. We're going to say router.get. Let's make a get endpoint for logout. This is going to be a restricted. Have the restricted middleware. Why does logout need the restricted middleware? Yeah, exactly. You can't log out if you're not already logged in, right? You have to log in before you can log out. So if you try and log out before you're logged in, it's going to say you're not authorized to log out, which is what we want. Make a route handler. This actually doesn't even need to be an async function because we're not going to be dealing with promises. So you don't have to make it an async function if you don't want to. And then if you look in the documentation for express session, press Control F or Command F and search for the word destroy. This is what we're looking for right here. This session.destroy function does just what it sounds like. It destroys the session and will unset the request.session property. Once complete, the callback will be invoked. So we can just call request.session.destroy, and that will destroy our session in the memory. And then it calls this function, this callback function, when it's done. And it includes any errors in the parameter. So let's just copy that from the documentation and use that in our logout function. Request.session.destroy. You can change this to an arrow function if you want to do that. And once that operation completes, then the session has been destroyed. What do we need inside of this callback? Some kind of a response, right? We also need to check for the error. What if there's an error? So let's just say if there's an error, so if error is truthy, then we can call next with error. Because we don't want to do anything if there's an error. We want to continue to the error handler if there is one. Okay, otherwise, return some kind of response. So we can just say res.json message you are logged. Okay, let's test this. Go into Insomnia. Remember, anytime you make a change in your files, your server is going to restart. And since we're storing our sessions in memory, you have to log back in every time your server restarts. So log back in, sets that cookie for us behind the scenes. We can call get protected, we're logged in, call get users, we're logged in. But now create a route for logout. Make a get request to auth/logout. No headers, no body, just a raw get request to logout. And submit it. You should get a message that says you are logged out. And now try and call get protected again or get users. And you should get a 401, right? Because we're logged out now. That session is destroyed. If we try and call log out without logging in, we should get a 401 as well, because that has the restricted middleware. Nice. We've got a nice session system going on here. So let me ask you a question. Is the cookie still valid after we log out? Notice we logged out, but Insomnia, if you look at the cookie jar, we've still got that cookie in there. Is this cookie still valid? Even though we logged out? It is. Okay, this cookie is still valid. Cookie itself is still a valid cookie. Okay, but the session ID that the cookie contains, that session ID no longer exists on the server. The session was destroyed. So the cookie is now essentially useless to this client. Okay, the cookie itself is still valid, still a valid cookie. It still gets sent, but it's not valid on the server. So when the server tries to validate that cookie, it sees that that session no longer exists and it doesn't authorize them. So this cookie is useless, even though it's still valid. It's important to know that when you delete a session on the server, there's really nothing that requires the client to delete the cookie. Okay, nothing requires the client to delete the cookie when you log out. It's really up to the client whether it wants to delete it or not. In this case, Insomnia, it's not deleting it. It's just keeping it in there. Even though it's useless, it just kind of sticks around. So nothing requires this client to delete the cookie. So if we were implementing this in like React, say, maybe when we log out and we have confirmation that the server destroyed that session, then we could probably just delete the cookie from there. Okay, so it's up to the client to clean up that cookie jar. Someone asked, what happens if there's a session, but there's no user in the session? Good question. What if the user gets deleted? What if the user gets deleted, but they're still logged in? Well, in that case, then the session would point to an invalid user, and we'd probably have to write some code to handle that. Right? You'd want to make sure, maybe in your restricted endpoint, maybe you'd want to make a database call to make sure that that user still exists before you try and use it. Or maybe you'd want to, when the user gets deleted, maybe you have like a delete user endpoint, maybe you'd want to make sure that all of their sessions get deleted at that time too. So there's different ways you could approach that. But it's good that you're thinking about that, right? You want to kind of make sure that your data is not stale. You want to make sure that your session's not pointing to data that has been deleted. So you can have some additional checks there if you want. Cool. Let's take another 5-minute break, and then we'll jump into the last part of this when we come back. Okay. How's everyone feeling? Make sure you update your poll. We've got a couple 1s and 2s, so let's see if we can get those up. Any questions specifically? Anything we can help to clear this up? Maybe you're not understanding the point of sessions or what we're using sessions for, how they work under the hood. Yeah, maybe it's just the tools that are a little confusing. It's all right if you don't understand the tools. If you're having trouble with like Insomnia or DB browser, it's the tools aren't as important. You can take the time to learn those. It's the fundamentals that are important. The concepts, right? Whatever works better for you. If you don't want to use Insomnia, if you'd rather use Postman, if you'd rather use REST client for VS Code, there's actually one that I use called PA. I like the one called PA quite a bit. I bought it like 5 years ago and I like it better than all the other ones, but it's cost money, so I can't use it in the lectures. Yeah, PA, P-A-W. Okay, so the last part of this, what if we want to persist our sessions to the database, to our SQLite database instead of memory? Right, if we want those sessions to persist between server restarts. In this case, we don't have a lot of control over express session, right? This express session library, it's kind of just doing stuff for us. It does a lot of magic under the hood. We don't have a ton of control as to what it's doing. So it's not very easy to manually make it save to a database instead of memory. We'd have to, go into the internals and maybe write a plugin or something. Luckily, there's a library that helps us do this, which is called, Vlad, you beat me to it. Quick typing. It's called Connect Session Next. Okay, let me give you a link to this. This is essentially just a plugin for Express Session that allows us to save our session to the database, to our SQLite database, instead of saving it to memory. So when we do this, it's a little bit slower to look up the session, right? Because we have to read it from the database instead of reading from memory. And reading from memory is a lot faster than reading from disk. But the benefits of having persisted sessions probably outweigh the speed hit that you take from reading from a database instead. Because we don't want all of our users to get logged out if we have to restart our server, maybe for like a software update, right? We want those users to remain logged in, so we can persist that data to some kind of memory storage, or like Redis or some kind of database. In this case, we can persist it to SQLite. So let's install Connect Session Next. I didn't even notice that. Username of the author of this is LL Lambda. That's not us, that's someone else. That's a cool coincidence. So npm install Connect Session Next. Get that into your package. Okay, and then restart your server. And jump back into your index file. Inside of our index, let's import it. So we're going to say const next session store is what we're going to call it. And we're going to make it camel case because this is a class that we instantiate with the keyword new. So it's convention to make that uppercase instead of lowercase. Connect next session store equals require, and we're going to require the connect session next. And this import is a little weird because we also have to provide the express session instance. So what we can do is just right after the require actually returns a function. So we can just call that function just by passing some additional parentheses and then pass through the session library so that it has the express session library, which it requires to run. So the same imports as before, but you just call the function right after you import it. And then while we're at it, let's import the dbconfig file. So in our database folder, we have this dbconfig that essentially sets up our next instance. Let's import that as well. So let's const dbconfig equals require /database /dbconfig. All right, Sarah, why does it not need to be in quotes, this session right here? Because this is a variable. We're not importing a package called session. We're actually just importing connect session next, and then that returns a function. This require statement, it returns a function that we can call, and that function takes a parameter of the express session library, the library that's already been imported. So this is a variable. This isn't a path. So variable doesn't require quotes. So let's look at the documentation in the documentation for express session. And if you look at, or do a Control F and search for the word store, find this session store implementation, this section. Actually, no, that's not the one we want. Oh no, yeah, that is the one we want. Scroll down to this section that says compatible session stores. So essentially, express session, it allows us to define any kind of persistent storage engine through all of these plugins. So if we want to store our sessions in like, I don't know, Couch database, CouchDB, you'd have a plugin for that, which is a type of NoSQL database. Or Cassandra, which is a type of NoSQL database. There's a plugin for that. Maybe you want to store your sessions in Google Cloud. There's a plugin for that, right? Maybe you want to store it in Firebase. There's a plugin for that, or Firestore. Mongo, right? Redis, if you want to store your session in Redis. In our case, we want to store our session through Nex, right? Which is why we use this plugin, Connect Session Nex. So if you scroll back down to the example, you can see how we do this through, actually, no, that doesn't have the example. Where is the example of how we use the store? There is no example. Well, I'll just show you. I'm trying to get into the habit of showing you how to find stuff in the documentation, because I think that's really important to know how to do. A lot of times I'll just come to the documentation and I'll just do a Command F, just a Control Find, and then search for some term. Sometimes it'll pop up. In this case, it doesn't, so you probably have to dig around in the actual code for the plugin. So the plugin gives us some options that we can specify. So let's first go into our config for express session, and we're going to define the value of store. We're going to create an object called store. And this is going to allow us to specify the backend essentially for our session storage. And we can use this session store library, this connect session next, just by saying new next session store. That's a function that we call, and we pass it an object, an options object. A new next session store. And we can get the options for this object in the documentation for connect session next. So if you look at the documentation, we have table name, we have SID field name, We have a next instance, create table, clear interval. We really only have to define 2 of these. We have to pass the next instance itself, just on the next key. So we can just say next and then pass our dbconfig, right, which is already a next instance. What else? We also have table name sessions. That means that when the table or when the sessions get saved to our SQLite database, it's going to be under a table called sessions. And then our session ID, the field name, is essentially the column name in our table. So under the sessions table, we're going to have a column called SID to store the actual session ID. Those are the default values for this library, so we can just leave those as they are. We don't have to define anything. See, it says defaults to sessions and defaults to SID, so we can just leave those. Create table, we can specify that if the table for sessions should be created automatically in our database or not. We probably want to set that to true, otherwise we'd have to create that sessions table in a migration file, right? We don't want to do that. Let's create the table automatically. So specify create table, true. Okay, that'll create the table automatically. And those are actually the only 2 options we need. You can also specify clear interval, which allows you to specify the number of milliseconds between the garbage collection, essentially cleaning up all of the unused sessions. But it defaults to 60,000 milliseconds, which is fine for our purposes, so we don't have to specify anything there. You can just have those 2 options and call it good. Now if we go back into Insomnia and restart the server, or restart the server in terminal and go back to Insomnia and log in, take a look at what happens in our database. Okay, before we do that, let's maybe jump into the DB browser and open our database file, which is just under, let's see, it'll be under, find the folder, under the database folder, and then auth.db3 is the file that we want to open. So look at that, just by installing that middleware, by specifying our store with connect session next, it automatically created our sessions table in our database. It's empty, but it automatically created that table. It created that schema, that migration for us, and it created these 3 columns. Column of SID for the session ID, ses for the session data, and expired, which is going to be a date. So it creates that sessions table for us. There's nothing we have to do. And now restart your server and try to log in, hit your login endpoint. Okay, it logs us in, but now go to your database and refresh that table. Look at this, we have a session that has now been saved to our database. We've got the unencrypted session ID. We've got the session data, which if you look at the session data, it contains like your username and your password and stuff that's related to the session, right? That user data that we that we set in our middleware. Contains everything that's related to our session. And then we also have the expired column, right? When that session expires. In this case, our session is expiring on January 24th, which is 7 days from now. Cool. So now if we restart our server, well, first of all, if we call our protected endpoints, we're authorized, right? Just as we expect, our session is valid. But try restarting your server now. So close it out, Control-C, stop your server, and restart it, and try to request those endpoints again. We're still authorized. Okay, it didn't delete our session even though our server restarted, even though we lost that memory, because it's now persisted in the database. Okay, what happens if we delete this row manually in the database? Delete that record and then write your changes by clicking Write Changes. And now try and request some protected endpoint. And it's not going to let us because that session was now deleted from the database. Log back in, and it creates a new session in the database for us. Okay, what happens if we hit the logout endpoint? Well, it logs us out, and it deletes our session from the database automatically. Cool, so now we have a persistent session storage. Really, really useful. Okay, question. In the training kit video, he said to name our session and replace SID, the default value of SID. He did the name monkey for security purposes. Yeah, I saw that in the training kit where he renames the session cookie or the session ID. It says name monkey for security. And honestly, that's actually doesn't do that much. All that does is it renames session ID to monkey so that it's not completely clear that you're using sessions. But anybody that knows sessions at all isn't going to be able to realize that you're using sessions, even if you rename that cookie. So honestly, it doesn't even really make that much of a difference. You can rename it if you want, but you don't need to. It goes back to the whole idea of hiding your stack. Like you don't want hackers to know that you're using Express. You don't want them to know that you're using Express session. But that only really goes so far, trying to hide your stack. Your protection against hackers should go into your code in actual like implementations, actual methods, not trying to hide stuff, trying to hide names and stuff. I hate to like go against the training kit like that, but like, yeah, hiding your stack really doesn't do that much in terms of security. I think that's a common misconception in the development world. All right, so that is it for tonight. Any other questions? Someone asked, how do we dynamically set the save uninitialized so the user allows us to save cookies? You really don't have to send like a value, like you don't have to specifically like set that to true if the user says so. All that does is we don't want to set a cookie if the user hasn't logged in. Like we don't want to just set a cookie for no reason. We're allowed by law to set cookies if the user logs in. Like we can still set that cookie with the session ID. We don't have to really ask for permission to do that because the user basically told us it was okay by logging in, right? We just want to set that to false so it doesn't set cookies before they log in. So you don't really have to make that value dynamic. You could if you wanted to like send a query parameter as part of the URL or something, but that might be more trouble than it's worth. Okay, any other questions? How are we feeling about everything tonight? Make sure you update your poll. That poll really helps me out just to give me a basis as to how everyone's feeling. So make sure you do that. We've got 47 people in this lecture. We've got 17 results on the poll. 18 people in the Slido. Geez. I didn't realize it was less than half of you that were even in the Slido. Yep, I'll push up the code after the lecture. So since we have a few minutes, let's do a quick introduction to the lecture you're going to watch on Tuesday, the video pre-recorded lecture regarding JWTs. JWTs are actually really simple. They stand for JSON Web Tokens, and it's essentially a way to generate a stateless authentication token. Okay, right now we're using sessions. Sessions are stateful, right? They require state on the server, whether it's in memory or in a database somewhere, they require some kind of state. Which means that if you scale your servers horizontally, meaning you spin up a bunch of different servers and put them like behind a load balancer for your application, they all have to share that. They all have to share that memory, or share the database, or share some kind of a storage space, so that they can validate sessions depending on whether or not. So they can validate sessions whether they were created on that server or not. So it's a stateful process. But JWTs kind of go a different route, and they try and make authorization not stateful. They try and make it stateless, so that when the user is authorized or when they're authenticated, we don't actually store any information about the session on the server itself. Okay, not in the memory, not in a database, or anything like that. All of your session data is stored in the token itself, in the JWT. And then it's cryptographically signed. It uses some cryptography methods to sign that key to make sure it's valid. Okay, so really the whole purpose of JWTs is to take this whole idea of sessions and remove the state from it, make it stateless. Okay, without any of the server-side storage, without storing sessions in memory, or without storing sessions in a database. And that's what a JWT does. You'll find out a lot more about it when you watch the video. And we'll have a Q&A on Tuesday to answer any questions you have, any further questions. But hopefully it shouldn't be too bad. Just go into it with the idea, with everything that we learned tonight, it's the same concept, it's just making it stateless. Okay, it's doing it without storing anything on the server. Cool. So your project is going to be part 2 of Tuesday's project. Same project you worked on Tuesday, but part 2 regarding sessions and cookies. So have fun with it. Good luck. And I'll see you guys for the Q&A on Tuesday. Have a good night, everyone.